Well, I'll just say, when it's a bunch of people, the tutoring turns into more talking. You know, it's one person, we can do some good tutoring. If there's two people, then as long as you guys promise your work, we can do it. I'll just say this: you scored fine. Yeah, you and Jackson scored fine. Everybody else in your row didn't do so high. Yeah, Breckton, you need to figure things out. All right. Now, also remember that even though it's the start of the quarter and that one quiz is probably going to make your grade look really bad right now, it is just a quiz. You pass the test, you turn in your homework, things will be fine. All right. Questions on the homework? Yes. Hurry up. No questions? All right, let's take a look at number 6. Take a look at number 6. All right, number 6 says the following. Condominiums, those are like apartments that people own, right? Condominiums in a new building cost $95 per square foot. Sam is looking at a unit. Unit just means one of the apartments. That costs $83,125. How large is the unit? It says that a unit costs X number of dollars per square feet. What does the word per mean? Mathematically, what does per mean? It doesn't mean multiplication. It means division, right? So it says that the condominiums cost $95 per means fraction bar, 1 square foot. Okay? And that will equal the C, cost. There's your formula. We were told, however, that what in our problem? We were told no. We were told the cost. The cost was, what was it, 85 something or other? 83,125. We were told 83,125. Okay. How large is that unit? Okay. So let's see. If that's how much it costs, and that's the formula right there. So you take $95 per 1 square feet. What we're saying is now we don't know, right? Therefore, when you multiply X on both sides, you would get the following equation. You get 83,125X is equal to 95. Well, let's see. So if 1 square foot is 95, then what would 2 be? Well, tell me mathematically what you would do. How about we multiply by 2, a little bit easier, right? Right. So we would take 95 and we would multiply it by the number of square feet, and that would equal the cost. Yes? Okay. So what do we do? Well, let's plug in our numbers first.
95 X equals 83,125.
Now what?
Now we divide by 95.
So this is really a division problem, not a multiplication problem, as I said from the start. Okay? So we divide both sides by 95 and get what X is. Okay. All right. Anyone else? Yes.
So
Genevieve. I'm going to have to look at it.
We can do number 1.
If you had done number 1, oh, by the way, we did number 1 in class. And that would be 365 times X is equal to 4,219. And divide both sides by 365, which we did that one in class. All right. Jace, you had a question?
It just told us not to solve.
It did, but remember in class I said I wanted you to solve. right? All right. Okay, I will collect that to see how you did. I need to see how you did. All right, this one. You're passing out. All right. What? All right, let's do this quickly, quietly.
Worksheet?
Yeah, today. Why are you not clicking?
I mean, it's like,
Like the one day I actually do my first.
I know, right?
All right. So here is your calendar. We got nothing but, oh, by the way, 9th and 10th graders on Friday, they will be doing something different than you guys. You guys will have class. They're doing a special class. It looks like, unless something changes, we're going to review on Friday. The test will be on Monday. So for those of you that did very poorly on the quiz, we got 5 days to fix ourselves in a weekend. Okay? All right. So it is a worksheet. I will say I'm fairly certain that none of you know what you're doing on this. You're going to need to be taught this today. Okay? What do you need? A pencil? Just borrow one from somebody.
Oh, it's this. Yeah, I don't know.
All right.
You were talking about this.
So I will say this on the level of complexity, like challenging or not challenging, this falls towards the not challenging side. However, if you pay no attention, if I look at you and you're reading a book or you're paying attention to the ceiling or something like this, this will make no sense. For those of you that aren't paying attention, you're going to be like, I don't understand why they didn't get it. It looks simple to me, and it is. But you do have to pay attention. So here we go. So it's an intro to inequalities. We will be solving inequalities for the rest of the week. Inequalities are solved similarly to equalities, but there are some different rules. Okay? All right, so inequality. Well, let's just contrast it with what an equality is. What's an equality? Somebody? What?
A number.
A number is not an equality. What is an equality?
It's an equation with the equal sign.
Okay, so it compares two values with an equal sign. So literally it's comparing two quantities, right? The quantity on the left and the quantity on the right. Notice the numbers are not the same. 2 and 6 are not the same as 1 and 7. So the numbers can be absolutely be different, but their quantity, their values have to be the same. So in other words, what I'm saying was I put in red there must be the same, simplified. 2 plus 6 is the same as 1 plus 7. So equalities simply say the left side is equal to the right side. That's literally why we can put that sign there. Contrasting that with inequalities, these are two expressions where they're not equal. They do not equal each other. Okay? This time, the left side equals 8, the right side equals 10. Right? Not only does an inequality say that they don't equal each other, it tells you how they don't equal each other. In other words, it's telling you which one is larger and which one is smaller. Now, I don't want to insult your intelligence. You've used inequalities before. You know, 4th and 5th grade teachers talk about alligators and things like that. I won't be talking about that. If you struggle with inequalities, you need to see me for tutoring. Okay? So that symbol right there is one of 4 symbols, it's technically 5, but 4 symbols that you can use for inequalities. There are the 4 symbols. I will still get 8th graders cannot tell me what the symbol is. Rarely do I get an 8th grader that uses the wrong symbol, but if I ask you to tell me the name of these things, I still see some 8th graders mess this up. Okay, this is the, see what I mean?
Oh, it's greater than.
No, I had people tell me both greater than and less than at the same time.
Oh, well, you said.
So if the symbol is floating there all by itself, there are no numbers around it, right? We call the first symbol the, okay? But I want to tell you, it can also be called the greater than symbol if you read it from right to left. If you read this from right to left, you get to the opening before you get to the vertex, okay? So if you were reading it from right to left, it wouldn't be the same symbol as you're reading it from left to right. And by the way, you can read inequalities either direction, left to right or right to left, okay? However, if the symbol, like it's shown right now, is floating there by itself, the top one is 100% the less than symbol. The second one down is the third one down is the, and the last one is the. But if you read these things from right to left, then you say the other word. And you're like, what do you mean right to left? I mean, 3 plus 7 is greater than 2 plus 6. Do you see what I just did there? Even though when the symbol floats all there by itself, it's called the less than symbol. We can read either way, just as we can read with an equation. 2 plus 6 is equal to 1 plus 7, or 1 plus 7 is equal to 2 plus 6. Who's confused? Okay? All right, some quick notes. Write this down, please, in box number 1 about inequalities. Wait a minute, that's not an inequality, that's a... It turns out there's 2 ways of writing that. There's one way, what's the other way?
4 equals X.
Write both of those so that you have that on your paper. Box 1. The same thing happens in inequality land. In inequality land, that is red. X is less than 4. But you could also read this from left to right. If we read this from left to right, it says, can you see how that works? Right? Now, if I want to read it from right to left, but I want to write it from left to right, then I'd have to write that. How many people did I just confuse by that sentence? Exactly. All right. So you got to be comfortable with this. Variable on the left, variable on the right, they both say exactly the same thing. It says that the value x, whatever that is smaller than 4. Second one says the same thing, except it starts off with a 4. It says the value 4 is greater than any value that x is. Who's confused? Good. All right. This says, in blue,
Equal to
and what would be the other way to write that? 4 is less than or equal to x. And they both mean exactly the same. Okay. No one is confused. Good. All right. First game of 4 I think we're playing today. I'm going to give you some words. You're going to write the inequality. If there's something that people mess up on, it's this one. We have a problem. Remember when we took a sentence and wrote an equation? And I said 4 is less than x? And you wrote?
4 minus
You wrote x minus 4, right? Guess what words you just used for subtraction? 4 is less than x. Guess what words you just used for subtraction? You literally use the words less than. But guess what? Less than can mean that symbol right there as well too. So we got a big problem. How do you know if less than means a minus sign, or how do you know that less than means the inequality symbol? Anybody know? 4 is less than x. Does that mean x minus 4? Or does that mean the inequality symbol? 4 is less than x only means 4 is less than x. Well, if it's just that, we got problems. Okay? That could be interpreted either way. Luckily for you, they're not going to be that hard. This is what you're going to see. All real numbers x less than or equal to -7. Okay? All real numbers x less than or equal to -7. How in the heck are we going to write that? Well, we break it down. What does all real numbers x mean?
a whole nother.
What does all real numbers
Positive
x mean?
numbers.
All real numbers x. It just
1x.
means x. It just means x. All real numbers x means that x could be any real number. Remember, the difference between an equality and an inequality is that an equality means one number, generally speaking. An inequality means any sort of lots of numbers. So that's why it needs to say all real numbers. All real numbers x can be written as x. Less than or equal to -7, you're not going to make a mistake there. You're going to write. I'm going to literally write less than or equal to -7. So it is written the way it reads in this one case right here. But it can be complicated. You probably aren't going to make a mistake on this one. This is the one that you're going to make a mistake on. Look what it says, less than, greater than. One of them is a subtraction addition. One of them is an inequality. Which one is which? What do you got, Brecton? Ah, Brecton notices that he sees the word is. Hint, hint, hint. In equation land, is means equal. So it means the symbol. It means the same thing in inequality. When you see the word is, whatever is attached to it, that's your inequality. So even though this says less than, it doesn't say is less than, right? And it's kind of more of a language arts thing than it is a math thing. You got to be careful with this. How do we write 6 less than a number k? What?
K minus 6.
K minus 6. So that first one is k minus, like, no, it's 6 minus k. That's not what it says. It doesn't say 6 minus k. It says 6 fewer than k. That's what 6 less than means. 6 less than, that would be minus 6k, is greater than 13. So I'm going to write greater than symbol. Well, there's a problem there. You got to know what the greater than symbol looks like. Who's lost? First one, fairly easy. Second one, confusing. So we better do some together. All right. All real numbers p greater than or equal to 1.5. What do I write?
P greater than or equal to 1.5.
That one's not too challenging, right? P greater than or equal to 1.5. The second one is the more challenging. It says some and it says less than.
Easy.
However, it also has a, Christian, it also has a, my eyeball would go to what word? My eyeball would go to what word? I gotta find the is, right? The is what's going to tell you where the inequality lives. Keep talking, Christian. The sum of t and 7, how do we write that? Sum of t and 7 must be t plus 7. Is less than, how do we write that? He showed me math gang symbols. He said that way, right? I'm just going to say, you got to be able to read words and write symbols. It is a challenge for some. Maybe on a resource card, you have this written down. Okay? Who's lost? All right, let's do one together, or let's do 2 of them together, box 2. We'll do the first 2 together. 7 is greater than or equal to x. That one's pretty simple. What do you think, Priscilla? What are we going to write? Show me math gang symbol. Okay, she did it right. Greater than or equal to x. She did that. Good? All right, second one together. 4 more than y is less. 4 more than. What do you got?
4 plus y.
4 plus y. Technically, that's y more than 4, but luckily for you, addition is commutative. If we really want to write it the way it's written, we would write y plus 4. That's 4 more than y. Keep talking.
Less than x.
Less than x. Okay. I know it's a minor point. You can't write it both ways for subtraction. Subtraction is not commutative. But y plus 4 is the same as 4 plus y. But if you want to write the way it's written, 4 more than means add 4. Doesn't mean 4 plus y. That's y more than 4. All right, last 2 you're doing all by yourself. We don't use that symbol ever again.
Oh, it's 4. I knew it.
Jade.
There you go.
Abby, do you remember what the word quotient means? Quotient means division. Except you're in pre-algebra, so we're not going to use the division symbol. We're always going to use fraction bar. You're like, well, why can't I use the division? Well, it's not that you can't. It's just that you're going to see as soon as we get this year and next year algebra 1, the division, what we are dividing ends up being expressions, not terms. So instead of just dividing one little tiny thing, c, we end up dividing x squared plus 3x minus 7. That's the denominator. So using a division symbol would require you to write with parentheses. We don't like parentheses, so we use a division symbol, or the fraction mark, sorry. All right, let's see. What do you got?
Me.
Oh, somebody new this time. What do you got, Angie? Second one? Third one?
4 plus 3 is greater
Show me math gang symbol. She got it. Okay. Occasionally I'll get students that they literally can't tell me the symbols. What? So remember, when you get these $10 words, quotient, difference, product, then you write it exactly the way it visually appears. Just for those $10 words. The other ones you got to read carefully. Go ahead, Jane. Last one.
2x minus 5 is equal to or less than. Sorry. Equal to.
You're saying it backwards.
Less than or equal to 0.
All right. So tell me what to write.
It's 2x minus 5.
Because 5 less would be written as minus 5. Yes.
Like that.
The product of 2 and x would be 2 times x. So he said 2x minus 5. I agree. Less than or equal to 0.
Symbol and 0.
Cool? All right, there's your task number 1. I give you words, you write the inequalities. I said 4 of these. All right, the next one, solutions to equalities. Hey, you should be able to do this. What's the solution? X equals 3, right? What will we do to both sides? Subtract 2 from both sides. You get x equals 3. That's a solution to an equality. We got a problem with inequalities. And the problem is this, right? There's more than one answer for inequalities. In fact, there's an infinite number of answers. It's not one number. What do I mean by that? Okay, you see the inequality? What makes this true?
1.6.
1.6 makes it true. 1.7. 50 makes this true. 4,000 makes this true, right? Lots of numbers make this true. So the question is, well, how do you solve inequalities? We'll explore that tomorrow. Today, they're going to give you some selected values and ask you, do they make them true or false? So for instance, does 2 make this true? Yeah. Okay. Does negative 2 make this true? Pretty easy, right? Does 175 make this true?
No.
Who said no?
My star student up here. And 1.5.
Yes.
No.
Yes.
1.5 is not greater than 1.5.
Oh.
So you better be careful. This is the tricky one that they always try to trick you with. They'll give you literally the number. Without the greater than or equal to symbol, right, it would be incorrect. But with the equal symbol, it is correct. All right. So the next game is, I guess you could call this a check step, right? They're going to give you an inequality. Technically, what you're doing, mathematically speaking, is evaluating it. In other words, you're going to plug in numbers to see if it makes it true or false. They will give you a bit more complicated one. Here's a 2-step inequality. And they will give you a number, -4. Does -4 make this true or false? What will we need to do? Not solve it. We could do that way. That would be the complicated way. How about we just plug the number in? This says that is -4 the answer for x? Everybody see what I'm doing? So all I'm going to do is take this -4, plug it into x, and see what happens. How come I put parentheses there? Because it's showing multiplication. If without that, it would look like 2 minus 4, right? It's not. It's 2 times -4. What is 2 times -4? And what's -8 plus 1?
No, it's -7. -7.
Is -7 greater than -3?
Yes. No. Yes.
No. Yes. No.
What happens with negative numbers? As the number increases, what happens to its value? It's smaller. So -7 is smaller than -3, so this one's a big fat no. Well, how about -1? Let's see if
Yes.
-1. Jenna, tell me what to do. Do what with it? Are you paying attention? Well, tell me what to do then. Jenna, we take the given value, look at the board, We take the given value, we plug it into wherever we see an x. I rewrite that inequality. Instead of writing x, I write -1. I'm always going to put it in parentheses. Then I'm going to do the math. What do I do first, Jenna? Okay, there's nothing inside the parentheses except one number. Nothing to do. Next. Hey, by PEMDAS, what do you need to do after parentheses? Well, technically exponents. No exponents. Then what? Okay, just say it, Jenna.
She said time.
Well, not loud. She did it with her hands, what she did.
Yeah, because you make fun of me every time.
Please.
Oh.
Rarely would I, well, I'm not going to say I've never made fun, but it would be in a jest, not in a specific teaching thing. 2 times -1, Jenna, is? It would be -2. What's -2 plus 1? Negative. Same or different signs?
Different.
Add or subtract. Big minus small gives me more negatives, more positives. So we get -1. Is that a true or false statement? Therefore, we put yes. Okay? All right. Now, what it'll look like tonight for homework is that they won't give you one number. They will give you a series of numbers to see if they work or they do not work. Anna, you with me? Right? All right. So does it matter which one we do first?
No.
Doesn't matter. I'll just say this. Pro tip. Either start greatest to smallest or smallest to greatest. Because eventually you're going to find one that either changes from yes to no or no to yes. And then every other number above it or smaller than it would be the same answer. Let's see what that would look like. This is box 3. Let's do it together. Here we go. I'm going to go from least to greatest. So the first number I'm going to plug in is -1. Be careful. Lots of negatives floating around there. Kai, what's the first thing we're going to do? PEMDAS, what's the first thing I do? Okay, there's only one number inside there. There's nothing to do. Any exponents? What's the next thing I do? Any multiplication or division? What am I multiplying? Say, stop it. That's not a 7.
-7.
Let him work through the problem. -7 what? Landon, do not say anything else.
I know. -7. -7.
What do you want me to do with a -7?
Multiply -1.
Do it.
-7. No,
Cut.
+7.
+7. All right, now what?
Subtract 7. Yeah.
He actually could do that.
You could, but it's
Right.
easier just to add.
Wouldn't it be just easy to add 13 and 7? Remember,
Yeah.
always simplify both sides. What do you get?
1.
True or false?
False.
Let him
I
answer.
thought that was a question for the
Oh.
That is false. Okay, so -1 didn't work. Everybody with me?
Yeah.
All right, Landon, or Kai, one more time. 0. Really quick. Do it. Tell me what to do.
All right. -7 times 0 is 0. So when we're
Yeah, but
13.
talk me through.
13 is less than equal to 6.
Which is
No.
which is a no. All right. So it looks like they're all going to be no. What happens when we throw a 1 in though?
Yeah.
Right. Well, we don't know if it's true or false. Let's see. -1 times -7 times 1 is -7. Negative times positive. Negative. 13 minus 7 is +6. Is 6 less than 6?
No.
But it's equal to. So this gives me a pro tip. Do I need to do the next number?
Yes. No.
If this went no, no, yes, then any number bigger than 1 is going to have to be.
Oh.
Yes.
Yes.
Any number bigger than 1 has to be a yes. I don't know if any number smaller than 1 has to be a no, because I went 0, 1. Maybe it's a decimal somewhere that it breaks even. But I do know that any number bigger than 1 is going to be a yes. Let's just prove that. -7 times 3 is -21. 13 minus 21 is negative, not negative 6,
Negative 8.
negative 8. And clearly, once again, because 6 is where, 1 is where it would break even. Any other number larger than 1 makes this negative become larger and larger and larger, which means it's going to, get rid of that value 13 really easily and give you a negative number. And any negative number is certainly going to be smaller than 6. Yes?
So right there, you put below it.
I could have, well, the issue with, is it below? If it's no, I don't know.
So like for both of those, there's plus signs.
Yeah, but I'm just saying, well, notice what happens is that when you're multiplying with this negative, eventually you get to the break-even. The break-even point is literally 6 equals 6, right? So anything smaller than that has got to give me something that where the number on the left is bigger. And anything that I evaluate that's larger than 1 results in a number that's smaller on the left side. So this is like the perfect scenario when you get 6 is less than or equal to 6, because it tells you that's the break-even point. That only rarely occurs. Usually they have you evaluate where they don't. All right, that's the only example we're going to do. You guys got that?
Yes.
All right, now we go to for many of you, this is the brand new thing of the day. This is like, okay, I haven't evaluated with inequalities, but it's pretty simple to do. Here comes the new stuff. All right, this is messy, right? Some kids make it look beautiful. I'm not one of them. So we are going to graph inequalities. We will be using this. It turns out that all of your answers when you solve an inequality are graphed, right? So the last game is called graphing the solutions, right? When we solve an equality, it's not always true. You'll see when we get into high school. But when you graph any, or when you solve any of the inequalities that we have been doing, how many answers do you get? Like every single problem that we've done so far, equalities, how many answers have we gotten?
1.
When did we ever get 2 answers?
Oh,
We always got x equals
Something.
something. We got 1 answer. Now, just so you know, in Algebra 1, and even this year, we will eventually get to where you get 2 answers for an equality, right? You could get more, but you won't see that until high school. But for equalities, typically you get something like x equals 3. How come we didn't graph that? What would the graph of that look like?
oh,
Well, you'd have a number line,
2,
and then what would you have?
you put it on
I put a dot on 3. Looks kind of boring, right? Does it tell you anything other than the fact that the answer was 3?
No.
So that's why we don't graph equalities, because it doesn't really show us too much. Now, I say that in broad general terms. When you get to high school, we're going to be graphing lots of equalities, but none like this. Okay. For inequality, different story. And the issue is because how many answers are here? Right? Infinite number. I mean, any number that is less than 3 is an answer to this. So it turns out that the reason why we graph inequalities is to show the reader of our work the fact that the answers are all smaller than 3. So what would that look like? Well, here's 4 examples that all make this inequality true. Okay? We graph inequalities because there's infinite number of answers. We don't graph equations, right? At least in this sense. When we solve an equation, we don't graph it. So let's see, how does this look like? You ready?
Yeah.
Now, I've given you the steps. They are in front of you. But this is how it's done, right? We aren't in kindergarten, first, second, third grade anymore. We all know, at least I hope so, let's find out, I'm the number line. The numbers to the left of me are what compared to me? In more general terms. Smaller. The numbers to the right of me are? So guess what you need for your number line? You need a whole bunch of numbers?
Yeah.
The answer is no. We do not need to make a number line that looks like this. Why? Because we all know that for number lines, the numbers that go to the right are, and the numbers that go to the left are. We also know that in a number line, 0 doesn't have to be the middle. I can make a number line that doesn't have 0 in it. But that number line still has the larger numbers to the left, to the right, and the smaller numbers to the left. Okay? So, though keeping that in mind, I will now show you how we will graph that inequality. All right. Step number 1 is, well, you got to have a line. Guess what a line always has? And I will take off points if yours doesn't have it.
Tick marks.
Arrows. It's a number line. Lines go on forever in opposite directions. Okay? Step number 2. I don't need that number line. This has way more information than I need. Guess how many tick marks I actually need? 1. Right? Some math teachers will make you put 2, or I'm sorry, make you put 3. I'm even more easier. I just say put 1. Guess where I want you to put the tick mark?
In the middle.
Smack dab in the middle. No, I don't want you to put 0. It might be 0, right? But not all number lines have to have 0 in the middle, because we know larger numbers are to the right, smaller numbers are to the left. I just need one number. Guess what number I want?
3.
I want that number right there. It doesn't say write a number, it says write the number. There will only ever be one number, that one right there. It could be negative, it could be positive, it could be 0. We put that number there. Now, other math teachers better than me will say things like, well, we should put a couple tick marks just to let the reader know. Well, if this is 3, clearly that's
4.
and clearly that's
Negative
what?
2.
2. And that number is
1.
I just say for in general that we're okay with number lines, and it just seems like extra work. So for me, I am okay with 1 tick mark. And the number's there. All right, now comes the new stuff. You ready? Is 3 smaller than 3?
No, technically not.
What if I had that? Is 3 less than or equal to 3?
Yes.
So we need to show our reader whether we want to keep 3 or not keep 3. That means is 3 part of the solutions or not part of the solution? Is 3 an answer to this? So how we show that it's not part of the answers is we put an indicator. If you have a less than or a greater than symbol, we say strictly less than, strictly greater than. If it's strictly less than or strictly greater than, we put an open circle. That means you don't fill it in. If it's less than or equal to or greater than or equal to, we put a filled in circle, meaning it would look like this. What does a filled in circle indicate? It means that 3 is the answer. Was 3 an answer to our problem? Therefore, we put an open circle. Open circle for these 2 symbols, closed circle for these 2. Closed circle means that number is part of the solution set. Open circle means it's not the solution. The last step is the hardest. We will shade either to the right or to the left. The shade will also include an arrowhead. Mine look horrible, okay? You better than me. So here's how it's done. Are you paying attention? We will read this sucker right here, and we will read it from letter, variable, letter to number. Except instead of saying X, we're going to say the solutions are. So let's read this. The solutions are,
4, 5.
read what it says.
Less than 3.
Where are the numbers that are less than 3? So guess which way we will shade. So this is the shading. And it should be a wiggle, 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 or a shade with an arrowhead. This is pointing in the direction of where all the numbers that make this inequality true. Okay? Let's see that again. N is less than 1. Draw a number line. Put a tick mark in the center.
1.
Write the number. Is this going to be an open or closed circle?
Let's give you an open circle.
Remember, an open circle means that that is not the answer. Closed circle means, yeah, it's the answer. Okay? We're not going to say n is less than, we're going to say the solutions are.
Less than 1.
Some people like saying the solutions are smaller than 1, that helps them, or the solutions are larger than 1. This one says the solutions are smaller than 1. Everybody see what I'm doing? Where are the numbers that are smaller than 1? So you shade left. Wiggle, 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 arrowhead,
Yeah.
or shade arrowhead. Okay? What's this say?
A is greater than or equal to
Number line.
0.
Tick mark. What's the number?
0.
0.
Is this going to be open or closed?
Closed circle.
That means this number makes this true. Okay? We read it from variable to number. The solutions are
Bigger than.
where are the numbers that are bigger than 0? So we shade right. Yes?
Yeah.
Okay. Now, I occasionally get smarty pant kids. I was surprised that Jaden hasn't said this yet. I bet he wants to say this.
I do want to.
Is there a cheat sheet way of saying which way to shade?
So if as long as the variable.
Oh, he's got the right answer. Stop. Now I need incorrect Jaden to talk. So Smarty Pants, very good, Jaden. Smarty Pants kid will look up here and they'll say, well, I can tell which way it shades. Which way is that pointing? It's pointing to the right, so therefore I shade the right. Well, yeah, guess what happens when you put the variable on the other side? Now it's the opposite. The solutions are bigger than 0, right? So I still shade to the right, and now the arrow points the other way. So for the other kids who are the true smarty pants of the class, always read from variable to number, and just read what it says. A is greater than or equal to 0. A is greater than or equal to 0, no matter which way, which side the variable is on, left or right. However, there are some true smarty pants kids that can keep all the. Jaden was good on that. That was solid, Jaden. They can keep all of this in their head and not make a mistake. Just be careful. Okay. All right, let's do one together. Box 4. How many people have already done both of these already? Don't put more than one on an inequality line or a graph. Sorry, inequality line. What am I saying? All right, so there's 2 problems here. Notice I got one variable on the left, one variable on the right. Draw me a number line. Oh, I did the whole darn thing. Put a tick mark. Write the number. The first number is, okay, is it going to be an open or closed circle? Now you read it. F, or the solutions are where the numbers that are bigger than -3, to the left or to the right? To the right. Okay, can you see why I don't have kids put more than one number? Does it seem like a waste of time? Okay. All right, second one, tick or number line, tick mark, open or closed circle. Closed circle. You read from variable to number. This says X is, because you read from right to left, remember you go whatever comes first, not the opening, the close, the vertex. X is smaller than -2. So where are the numbers that are smaller than -2? To the left. Yes?
Yeah.
Okay. We got to do one last thing. Guess what it is?
We have to do the opposite.
You got to do the opposite of what we just did. So the opposite, get it?
Boo.
So the opposite is, I give you the graph, you write the inequality. Hannah, pick a variable. Don't overthink this. Pick a variable. X, I pick G. Okay? You pick any one of the 26 letters and you write it down. Hey, what's that number? I don't care if they give you a whole bunch of numbers, and they will tonight for homework. You just pick the one that's underneath the circle. That number is, you write it right there. Now you have to be smarty pants. Open or close circle. So we know that it's either going to be this symbol or that symbol. E-learners, I'm showing less than or equal to or greater than or equal to. The question is, where are the solutions? Are the solutions bigger or smaller than 13?
Smaller.
So which one says less than? That one. Therefore, it will be the less than or equal to. Be careful. If you put your variable on the right side versus the left side, it will make a difference. Anybody confused on that? If you put it on the left side, you will always get this right. Okay? You can't put it on the right side. All right, let's see another one. Let's see. I need a variable.
X.
I put G. All right. What's the number? Tonight for homework, we're going to have all the numbers. Just pick the one that's underneath the circle. Open or close circle. So that means it's either going to be less than or equal to or greater than or equal to. Read what it says. The solutions are bigger than -1, so we need the bigger than, which is the greater than or equal to symbol. Okay? So G is greater than or equal to -1. Yes? All right, you have 2 in front of you. Box 5, box 5, box 5. That's it.
Yeah, it's all of it.
I did it.
It's all done.
You can also just like look what way the
Kai wrote his backwards, and he got both of them right. No. You wrote backwards in how I always put the variable on the left, but you wrote yours variables on the right. You got them both right. Very good. What?
So I feel like if you always put the variable on the left, you just have to see which way.
Yeah, I'm with you on that. Just be careful because of the other way around, they will mess with you. Yeah.
So is 7 correct or
Is what?
7?
I can't hear what you said.
But it doesn't.
Doesn't what?
It's not filled in on our sheets. Yeah.
Oh yeah. Apparently, yours is different than mine. I don't know if that printed off. Yeah, because I think it just printed off wrong. I printed this off in black and white. I bet that's what it did.
I thought the top was.
Well, yours is going to be different than mine.
I know the top was shaded in because it had like.
Yeah. No, this is what it should, for some reason it didn't print off on yours.
So do you want
Oh, this is definitely a formatting error. So for mine should say what? Well, we can all agree on the first one's the same thing as yours. So the first one's going to be what? X is less than 11, right? I put G. The second one, yours is open, so yours will be
-7 is less than.
Gotta think about that. He's right. You wrote yours backwards though, and he read his backwards. So the second one for yours
X is greater than
should, because yours is open, if you pick X, X is, well, the numbers are
that which was greater than or less.
so greater than or equal to -7. Mine is filled in, so I would have that right there. Okay. Now, if you wrote it backwards, right? Kai wrote his like this, and he had negatives. He had X on this side.
I wrote it backwards and read it.
I know you did fine. All right, questions. We got a solid what? 1 minute before the bell rings.
No.
Okay, the very first page, you're going to draw the inequality. I've already given you the graph. On the back, it has the inequality. You are going, or the graph of the inequality. You are going to write it. All right, everybody else, graph one on your way out.
Alright, I'll give you
Graph one on your way out.
Oh yeah.
I'm just gonna leave it because. Yeah.
I'm right here. Oh, hi.
Anna, you got one? Got one? Have you ever done this before? I was pretty complex. You may.
Oh, I like how full it is in here. Why is it never a secret? This is so small. I'm back.
My gosh. Gotta take my mask off. Don't. Carson, I forgot. No, I forgot to take my
It's well, I need a new spot because I can't see from where I sit now.
Where do you sit?
All the way over there.
Well, I'm not sure if I even have any open spots.
I can't see it from my
Can you sit next to the printer?
I can't see it. Yeah, that's
All
right.
right. Well, yeah, but you don't sit next to the printer.
Can I go to the bathroom? Yeah, I do. I could swap.
What? No, the other seat next to the printer.
Oh.
All right. Sit right there for today. See if that works for you. What? No, not right now.
Is this rotation?
It can be lots of things, right? Oh, class hasn't over yet.